Here we are with Professor Thomas Boving, a professor in the departments of Geosciences and Civil Engineering at the University of Rhode Island. The Rhode Island Water Resources Center has chosen to support Dr. Boving in his research of a topic he's going to explain here.
Yeah, thanks for having me. Very excited. This is a great opportunity to talk a little bit about the research we're doing here on the campus of the University of Rhode Island. This project you mentioned, it has to do with the quality of stormwater. Stormwater runoff, as you know, contains not just particulates like dust and pollen. You know, right now pollen season, many people have allergies, but also residuals from burning gasoline, from rubber, from tires, from automobiles. So many contaminants that tend to accumulate. That means they get into the atmosphere, but then they have to eventually settle out. So these contaminants, of course, are of concern because who knows where they end up. So the question we asked, can we find out? Can we find out how much of this contaminant ends up?
All right, and the title of your project is?
Measuring the deposition of, that's a mouthful, polycyclic aromatic hydrocarbons, which is a group of chemicals that are very common in gasoline products. In particular, once you burn gasoline, the leftovers of this incomplete combustion process is forming chemicals that are called PAHs, polycyclic aromatic hydrocarbons. This is a fairly complicated looking chemical or groups of chemicals. Just briefly, you don't have to be a chemist, but just imagine benzene rings, these hexagonal structures, 2, 3, 4, 5 of them glued together, so to speak, make up these contaminants we're after, and we call them PAHs.
Okay, so the sources of these contaminants are gasoline?
Incomplete combustion. That's another big word, but think cigarette smoking.
All right.
Have you ever smoked?
No.
Oh, good for you, because if you had, you probably would have had a pH exposure. Some of these compounds are very toxic, carcinogenic. So any smoker generates, by lighting up, by the combustion process, by smoking, a stream of PAHs.
Right, and I would be contributing to pollution.
Yeah, in this case, pollution of the lung, but we are now after the pollutants that get emitted from cars.
Okay.
So they end up in the atmosphere.
All right, and how do you plan on measuring these contaminants?
Chemically speaking, they're easily detected using a method called gas chromatography, meaning once we have caught them, sampled them, we inject them in a fancy instrument you see on CSI or these shows, and we can quantify them. The trick, however, is to first of all catch those contaminants, and that's where our project comes in, because to measure the influx, the deposition of PAHs coming out of the atmosphere and onto the surface of streets, roads, parking lots, and such as, we have designed a instrument that captures some of these contaminants and accumulates them on a specially designed filter that holds on to these contaminants. And we need to do that because the influx we expect, fortunately, is fairly low, fairly small. Okay. So we have to sample over up to 3 months, maybe even longer, to capture sufficient amount for analysis. Okay.
In your proposal, you mentioned that you'll be analyzing this every quarterly, so every 3 months.
Right, that's the idea. Initially, we just have to assume that it will take 3 months for sufficient pollution to accumulate in our filters. It may well be that the air is much more polluted than we think, and in the future we can measure after, let's say, a month or so.
Okay.
Or the other way, only half a year, something like that.
Have you yet installed the sampler?
We have tested it during a period 2 years ago, and have shown that we can actually measure these contaminants. So the instrument works. We had some issues with frost, where one of our instruments was broken because in the winter the glass funnel we used froze up, the water expanded, and $700 later. But yeah, we have solved these issues, and this is, by the way, an instrument that was developed by our friends at the University in Tübingen in Germany. Mm-hmm. Their group has designed the method, has developed the instrument, and in fact has given us 2 of theirs, and we purchased another few for measuring the flux of these contaminants.
Okay, and what will be the sampling area once you do install it?
Yeah, so initially it will be the sampler we will install on the campus of the University of Rhode Island with basically in mind that we like to have a good eye on the instrument. Like I said, it's not a cheap instrument. Vandalism is always a problem. Second, we like to take our students to the site and show them what we're doing. So it makes sense to begin right here on campus of URI. However, later on, we would like to expand and go, let's say, close to the city of Providence. Densely populated areas, we assume, will have higher amounts of contaminants. So Providence, maybe way out there in the boonies, so to speak, where maybe the flux of those contaminants is much lower, maybe not, we simply don't know. So ideally, we would like to create a network of samplers spread over Rhode Island and possibly later nationwide.
And what will you be doing with these results once you do find out the quantity of contaminants that are being?
Well, yeah, so that's a good question. So first of all, we have some ideas what to expect, as I mentioned earlier, from studies that were conducted in Europe, in Germany, southern Germany in particular. And there's clear evidence that the influx of these contaminants from the atmosphere to the surface of parking lots and roads contributes to the overall contaminant load that then, come a rainfall, washes off and runs off with the water into nearby ditches, nearby drainage structures. And the problem may be that these contaminants accumulate. So we try to figure out how much is coming out of the atmosphere, how much is contributed by direct car emissions to the surface, how much is contributed, for example, due to oil spills or leaking, dripping cars. And we're on the campus, so you can imagine what kind of cars are being parked here, 150-year-old Chevys and such. So bottom line is we need to know where are the contaminants from. Do they mainly originate from the atmosphere? If not, how much is the contribution from other sources? And then we can design remediation strategies for cleaning up the polluted water.
All right. Also, the stormwater demonstration facility is tentatively approved by the Rhode Island Department of Transportation, and that is on the URI grounds. How are you incorporating that within your project?
Well, yes, we were happy to be able to work with Rhode Island Department of Transportation, and we got tentative approval for installing a stormwater treatment and demonstration facility here on campus with a goal to test methods to treat the stormwater runoff. Bottom line is how to get rid of the pollutants.
So the next step after your project, the conclusion of your research.
Yes, it's basically tying all together because we now have a treatment facility on campus which is heavily instrumented, heavily supervised, and right on campus, which allows us to go there day and night. And the fact is that when you deal with stormwater runoff, you're talking about storms. You have to wait for wet weather. Sampling wet weather is really not easy because you can't predict when the storm hits, how long it will last. It means you have to mobilize on very short notice a certain number of helpers, students that are out there in the field sampling. If it's right on campus, it's so much easier because you can say, all right, there's a storm, let's go out. If it's 20 miles somewhere else, 100 miles away, you'll never get there before the storm starts or it's already over by the time you get there.
Okay. The Water Resources Center here in Rhode Island, they place an importance on enhancing the education of students in the water resources field. How are you incorporating student participation within your research?
Right, that's a good question. Foremost, this is the University of Rhode Island, so we are foremost interested in educating our students and involving them in up-to-date, cutting-edge research. And this facility and the center allows us to do just that. So, for example, once the demonstration site is installed, it is within walking distance. We can take our students, 'em, 'em, to the site and show them hands-on. This is, for example, a 30 meter swirl reactor, hydraulic separator. These are all technical terms, but these technical terms describe instrumentations that, let's say, a road construction engineering company would use to treat stormwater runoff. So we're going to have a few of these structures on our testing facility, and we can show the students what they're looking at. This is where the water comes in, this is the water gets out. This is what happens inside that technology. So it will be an excellent opportunity for our students to see firsthand, right on, what they may expect later when they're out there in the field and working for a consulting company or an engineering company.
Okay, as far as graduate students, are you going to be enlisting the help of a graduate student for your project?
Absolutely, absolutely. The plan is to, in the medium to long term, involve at least one graduate student continuously and possibly a PhD student who will be in charge of the site, basically adopt the project, make this his or her project, and also serves as an ambassador, because all these beautiful results we're going to generate are useless unless we communicate them with those who deal with these kind of issues. So the Department of Transportation, the consulting companies, the engineering companies, they only learn from our results if they are aware of them. So our student involvement is such that the student will serve as an ambassador for the site and will be writing reports, press releases, giving tours if that's what people like to do. So yeah, there's going to be a lot of student involvement.
Okay, and in 2005, I believe, you did a project for the Water Resources Center, the contamination of a POSCO well.
Yes, oh yeah.
How is that similar to this project?
Well, yeah, that's a good question. I guess the biggest similarity is that we're dealing with the contamination of water, and the contamination of water by hydrocarbons that are related to gasoline. Mm-hmm. And in the case of POSCO, that would be the usual suspects, the benzene, the xylenes, again, without going into too much detail, the contaminants that are in gasoline, plus a compound that is now not in the gasoline anymore. It's called MTBE. It's an additive that was added during many years as a substitute initially for the lead, the anti-knocking agent, the tetraethyl lead. MTBE was added to get rid of the lead. Turned out that the MTBE itself is a huge problem. When it gets released to the water, it travels rapidly with the water. It's very little degraded, meaning bacteria don't eat it, so that MTBE, when released to the environment, poses a problem. And in case of POSCO, this is exactly what happened. There was a spill at a gas station. The local well field producing all of POSCO's groundwater was down gradient, and in fact, when operating, pulled that contaminated water right to where the people get their water from. So within a short period of time, people noticed bad odors, bad tasting water, and a laboratory analysis confirmed that indeed there were high levels of this MTBE compound. In consequence, the well field was shut down. That all happened in 2001. Big issue because overnight people had no water anymore. And we're talking 5,000 people in this town of POSCO. What can you do? I mean, you have no water. So these folks had to basically rely for some amount of time on water bought in supermarkets, gallon jars, but you can only do that long. Have you ever tried to take a shower with a gallon? So eventually the whole issue went down to a lawsuit, and that lawsuit basically dragged on because the nature of these lawsuits is that one has to be very carefully in showing evidence that indeed the contaminant released from that particular gas station caused the contamination at that particular well and will cause continuous contamination if not being remediated. And then it becomes a matter of summing up the costs that are involved in cleaning up the mess and or finding substitutes in case the well field cannot be cleaned. So bottom line is, ever since 2001, the town of POSCO, the people of POSCO have no water of their own.
They haven't since reopened the well fields?
Nope, they have not.
Do they have plans to?
Yes.
Okay.
Yes, so the hope is that the lawsuit that is currently going on will eventually result in one form of a outcome that will allow the city, the town of Pasco, to either reopen the well field or find a substitute.
Okay. And how is that a point source, as in your current research here for the influx of petroleum hydrocarbons is a non-point source? Could you explain the difference?
Oh yeah, big difference. The release of a contaminant from, let's say, a underground storage tank, like a gas station, a leaking underground storage tank, is what we call a point source, meaning we can pinpoint the source of the contamination right there.
And that would be Pasco?
That would be Pasco, exactly. And these point source problems are very common. Think gas stations, think industrial sites, military installations. You can pretty much put your finger right on where it happened. Whereas in case of what we're trying to do here on campus with the atmospheric fallout, this is what we call a non-point source of pollution, meaning the cause of the pollution cannot be pinpointed. It's not this car alone, it's the many thousands or millions of cars that drive around the Northeast or the United States. So they all put together cause the pollution problem. It's kind of, in old days, acid rain. I don't know if that still rings a bell, but...
familiar phrase, just
yes.
doesn't seem applicable right now.
Yeah, because we were able to fight it. It was one of the great success stories where, in fact, legislation by EPA Clean Air Act had a tremendous impact on what's called the acid rain. Again, caused by industrial pollution, non-point source. Many smokestacks emitting gases. These gases mix with the rain, lower pH, cause trees to die. That was basically a classical example of a non-point source pollution problem. Now, with the many cars and the exhaust and the fumes containing these pHs, these compounds we are looking after, same thing, non-point source. Very difficult to pinpoint where it's coming from, but measurable impacts over large areas. And that's exactly what we're trying to quantify, how much of these pHs come in initially Rhode Island URI campus.
Okay, and when do you plan on installing the sampler?
In fact, we have a meeting tomorrow. The samplers are already there. We ordered them. We will basically be able to install them as soon as we have a fence around, because, again, the nature of the instrument is very delicate. It's a glass funnel about this big on the top, narrowing down, eventually resulting in a tube where the filter material is, where we capture those contaminants. And it will be set up about 2 meters or 8 feet, whatever you prefer, above the ground, 6 feet, I guess. I'm German, I like my metric system. Bottom line is we're going to set it up, and then we don't have to do much. We just have to wait for rain, for dry deposition. But again, it is a very fragile instrument, and we're just waiting to set up a fence and ready to go. And
what's trapped in the filter will later be analyzed on the campus of URI?
Oh yeah, absolutely.
In our labs?
In our labs. We have all the instruments we need. The material is an organic sorbent, an industrial sorbent, doesn't matter what the name is, but bottom line is it is designed to specifically attract these contaminants and don't release them. So once again, when they hit this filter material, they're there. But we can then use chemical solvents to leach them out. After the 3 months is over, we take the filter to a lab, leach out the contaminants, concentrate them, inject them into our gas chromatographs, and then we're going to be able to identify those compounds and also quantify them. So we know exactly how much is there and what compounds are we dealing with.
And what are some of the consequences of these contaminants in our water?
These compounds are very toxic. Mutagenic, carcinogenic, tetragenic, all these beautiful words which describe basically very dangerous and possibly deadly compounds. And we simply don't know enough about these compounds. It is unfortunate that we're releasing tons and tons of chemicals into the environment, and we simply don't know what the consequences are. And I can go on. This is not just limited to pHs, but pharmaceuticals, personal care products, lots of chemicals that are produced at an industrial scale, released to the environment, and we simply don't know what they do.
All right. Well, it seems as though it's a very encompassing project. You'll begin with quantifying and later possibly finding solutions for the problem.
Yeah, absolutely. Absolutely. That is, a big outcome is to first understand the magnitude of the problem, and maybe there is no problem. I mean, we have to be honest. If the influx of these contaminants relative to other sources is
exactly
small, negligent, small.
Small, not negligent.
Not negligent, exactly. So if there's not a problem, then fine, that's good. However, if we have evidence that the influx of these contaminants is significant, then we can design particular solutions that can be either addressing the contaminant at its source, meaning at the exhaust pipe of a car, which would require, obviously, changes in the design how we build cars, or at the source or at the other end of the system where the water is being collected, the stormwater runoff, which is ultimately the sink of these contaminants. So after a rainstorm, the water enters the ditch drains into a pipe, the pipe enters into, let's say, a retention pond or Narragansett Bay. Where we want to catch the water is before it goes into these systems and before it enters.
Sounds practical.
Yeah.
All right, well, possibly we can interview again after the results from your project have surfaced.
Absolutely.
Hopefully good results.
Yes.
And we thank you for listening to I and Dr. Boving on his research project for the Water Resources Center.